Hello, everyone, and welcome to the Indiana Nomad podcast, sponsored by DataShapes, the experts in all things signal and waveform AI. I am your host, Logan Selby. This podcast will introduce various experts from different industries from around the globe to give their thoughts on technology and how it has affected them personally and professionally. We will spend time understanding how innovation is changing their industry and where each guest sees the evolution going in their respective field. I hope you enjoy, and feel free to follow us on Instagram, Twitter, or our YouTube channel at Indiana Nomad. Hello, everyone, and welcome to the Indiana Nomad podcast. This episode is a special one. We got a good group assembled today and to discuss mission-critical networking and communications. So to kick it off, I'm going to go around the horn and introduce everyone. So as always, we're joined with Junaid Islam. If you want to know more about Junaid, feel free to check out our last few podcasts. Junaid goes into his deep background, which is really interesting. So if you want to check that out, please have a listen. We're also joined again by Randy Clark. Also, if you want to check out Randy's background, just in interest of time, check out one of our last podcasts. But today we welcome Dr. Walt Magnussen to the conversation. And Walt, do you want to give a little bit of your background for the audience?
Sure, Logan. I appreciate it. And by the way, I'm honored to be here today. I thank you very much for the time and everything else. And sounds like it's going to be a good conversation here. I'm Walt Magnussen. I direct the Internet2 Technology Evaluation Center at Texas A&M University. And we are a center that focuses primarily on interoperability, interconnection, and that type of thing in the NG911 space, in the public safety broadband space, 4G, 5G, and support the applications that need to be prioritized on top of it. Our center has been in existence for 20 years now, and our largest customers are the Department of Homeland Security, the Department of Defense, Department of Transportation, and now we're really basically getting started and doing work with the Department of Energy as well.
Great. Well, I appreciate that background, Walt. And again, it's a pleasure to have you on and looking really forward to this conversation. So to kick it off, I'm going to turn it over to Junaid to kind of introduce the topic that I mentioned in more of a technical fashion. So we'll go over kind of where we're going to take this conversation. So Junaid, take it away.
Great. Well, thanks for having everybody, and thanks for the people listening in. For those of you who have looked at our previous podcast, and I encourage you to do it, the last one was with Glenn Haddock, who's an expert on energy. What we really try to do is bring a subject matter expert, in this case, Dr. Walt Magnussen, to really help explain the complexity and challenges of these new systems. On our last podcast, we looked at energy and how smart energy is actually adding more pressure to our energy grid, making it more vulnerable. And then, of course, we have cyber attacks, which further adds to the fragileness of our energy grid. Today, we're going to talk about something that actually affects all of us, and that is first responder communications. Unfortunately, as we have large-scale forest fires or floods, it does require people from different counties, ambulance, police, to come together. Also, FEMA shows up. And this is a really complicated problem because everybody's on a different network where they normally are, and then they switch to yet a different network, and then people actually have to work together. How does an ambulance on one carrier network talk to another ambulance on another network? How do they even know they're in the area? This is all quite complex. And part of the reason this is becoming a bigger topic is as we look at smart cities and smart transportations, we are becoming even more hyper-connected. So as we have the challenges today, as we look to the future, having secure comms, reliable comms that is RF aware, that has security built into it, that has an identity system so it knows who people are even on different networks is critically important. So what we'd really like to do is, kick it off by getting a perspective from Dr. Magnussen on what he sees as the big challenges and opportunities. And then, we'll go into a group discussion actually read by Randy Clark on some of the things we need to think about. So with that, Dr. Magnussen, thank you for being here. We'd just love your perspective on, what are the challenges, but also what are some of the opportunities you see that we need to look at in mission critical comms?
Okay, well, that's quite a mouthful there, Junaid. What you got to keep in mind when you're talking about critical communications, what you're looking at is something where if the message does not get through, lives could possibly be lost. So, in terms of the pecking order of what's going on out there in the communications world and everything else at the time, you have to basically juggle, or how do you have to prioritize the information that is being attempted to be conveyed by the first responders. But also keep in mind when you're dealing with a large scale disaster and stuff like that, you've got the commercial folks that are in essence on the same network. They're prioritized, the first responders are prioritized, but the commercial users are still on the network as well. They outnumber first responders by a large amount. Figure 300-400 million commercial users on the networks, and you've got about 10 million when you look at public safety, about 10 million devices possible. You've got about 20 million in defense and maybe another 10 or 15 million in utilities. So a small fraction of the overall traffic is really considered to be used by eligible critical communications users, or in other words, prioritized users.
So, as one of the things you touched on, and thank you for that introduction, you kind of laid out a big problem. How do the 10 million first responders communicate across this network with 300 million people? I mean, what are some of the challenges you see today? And then what are your some thoughts on how it should work?
Well, again, from the service provider aspect, they have a tough job of trying to figure out how do you make the two interoperate, because really, how do you make the two basically work side by side? At the time that you're prioritizing or basically ramping up the public safety traffic and everything else, think about what the citizens are doing. The citizens are also in the middle of a disaster. They're wanting to call their loved ones and notify them what's going on. They want to send out videos and everything. So what happens is, while most networks are designed for what we consider blue sky days, most networks are designed for daily operation. We can conceivably hit 3, 4, 5, 10, 20x normal traffic during any type of large incident. And it doesn't have to be a disaster. We see that here when we bring 103,000 students into the stands for an A&M football game on a Saturday afternoon. So it can be caused by a large number of things: Balloon Fest, 4th of July on the Mall in Washington, D.C., but all of those types of events basically ramp the traffic way up. So in essence, if you kind of look at it now, you've got the demand level here, and you've got the available traffic levels here. So you have to figure out how to go ahead and not completely take away everything from the citizens, but yet still meet the needs of the first responders. And then you couple that with the fact that, prioritized is not the same priority for everybody. If you look at things like current wireless priority service, WPS and GETS, president has a top priority. Governors are basically right below that. And then, folks like me are pretty much at the bottom of the heap. But, there's a priority based upon the role. And then there's also a priority based upon the application, because video will work reasonably well, but it has to have a certain amount of throughput to be able to do that. Voice doesn't take as much throughput, but it can handle a lot of delay or variance in delay, which we refer to as jitter. So in essence, different types of traffic have to be treated differently. And, so that's really kind of setting the controls in the network so that all of these things that we're trying to manage and control at the same time are happening.
Based on your comments, I guess three things kind of just rush to the forefront for me. One, at the most basic, if I thought of myself as a first responder, is there a wireless network there or not? I mean, when I think about a flood or fire, you think of the mobile network could disappear itself. So how do you know as the sorry. How do you know as the first responder, as in you really are the first responder, you're first on the scene, what's available there? And then So one is, RF visibility awareness, and the RF could be changing while you're there. If there's a fire, maybe it's starting to eat up the towers. The second one is, getting onto the network. How are you prioritized, right? So, is there RF awareness so we know what's going on? Then is there prioritization, and what is it like on a multi-network basis where we have a mix of carriers, the large AT&T and Verizon, but we also have new carriers like SpaceX who are wrapping back in to the internet. And then the third is, once I get past the RF basic, then the prioritized connectivity, then I need to have a secure channel, right? Because my understanding is the traffic and communications between law enforcement is legally protected or needs to be secure, especially in emergency. So can you comment about the, my perspective is these three problems arrayed one on top of how do I know what's available as a first responder? Then how do I can I get prioritized connectivity, or how easy or not easy is it? And then the third part is there a way to secure it?
So, one of the big areas right now, public safety is looking at the whole concept of PACE, where you've got primary, alternate, contingent, and emergency. So we are doing different things in each of those areas to really try to go ahead and make the situation better. Primary, you've got public safety broadband networks where the service providers are prioritizing the traffic. And that always needs to be your primary way of communication, because a lot of money's been invested in doing that. And in essence, it's very solid, but it's not 100%. So that's where the ACE come in public safety communications. Some of the alternate solutions are, some companies or some jurisdictions right now are utilizing multiple SIMs from multiple service providers. That can get to be somewhat costly. If I go into an area like Florida a couple of years ago where the hurricane hit and there's significant outage of the fiber, none of the service providers might be there. So a lot has been done in terms of deployables where I bring a unit with me. We just recently completed a series of tests of a unit that's permanently installed in a fire truck. And when that happens, that fire truck brings with it a core, RAN, and everything you need to be able to operate a network on your own. And then kind of the last part of that, an emergency, the last part of it is we worked with Qualcomm in rolling out some side-link technology at the interoperability plug test in Malaga, Spain about 3-4 weeks ago. And there, kind of for the first time in the world, we demonstrated the capabilities of doing LTE device to device. And that is going to ultimately be the final way of communicating when you have nothing else, because, first responders count on that heavily today. Call it talk around and land mobile radio. How do you do that in LTE? Fortunately, the specifications and the standards have been there to do it, but we have to get by the other problems. One of them is, how do we operationalize it as first responders? How do we actually, get in the hands of the first responders, but then make sure that they understand how to properly use it? Once we figure out how to operationalize it, then basically the service providers have to figure out how to commercialize it. What's the service offering going to be? What are we going to charge for it? How are we going to support it? And then from there is the technology aspects of it. The technology is quite a ways along with things like SideLink, and it's really far along in terms of the private deployables. FCC has also provided some frequencies that are available for that type of thing too. So you don't have to be a service provider to be able to deploy it. By using CBRS frequencies, you've got the ability as an end user to deploy your own as well. So a lot of the pieces are coming into play, but we as a group need to figure out how are we going to make this actually work.
Now, of course, you've been talking a lot about what we're doing right here in the United States. Are there any lessons learned from other environments such as Europe, where they certainly have not just different counties, but different countries that we could kind of leverage? I believe you're in Europe recently.
Yeah, great question. Late last night, I got back in from Krakow, Poland, where we met with about 20 different countries. that are working on the questions we are discussing here right now are being asked in Finland and Sweden and Denmark and Poland and France and Germany. So they meet fairly frequently over there to discuss how to work together, because interoperability there is not a if, it's a must. They are in a situation where a single incident can easily involve 2 or 3 different countries. They've had high-speed drug chases in the past that have crossed several borders going across Europe. So as a person goes from country to country, the first responders need to be able to have a coordinated response effort so that they can keep things going. That's just talking about public safety. In most of Europe, I've experienced that the public safety and the defense networks are actually one. So in Finland, for example, you have the Verve network, and that is designed to support public safety and defense. So, they're looking at the exact same questions. So one of the big takeaways from the meeting, the last 3-day meeting out of Europe, was, how do we work together? We've got the same problems. We've got the same technology. We've got the same issues. How do we work together to answer those questions? And instead of having each country come up with their own answer, how do we collaborate so that, in essence, we can get a lot more bang for the buck? Most of the European countries are spending millions and millions of dollars trying to answer these questions. Department of Homeland Security is in the same boat. They're funding projects to answer these questions. So working together would obviously make a whole lot of sense.
So, there's obviously a organizational and political issue, but also technical. I thought we could kind of open it up to the group and ask Randy Clark. Randy's been looking a lot at the technical challenge, everything from the core 5G switches just connecting, just being able to connect, to the prioritization, to the RF awareness, to the making sure the traffic is encrypted. Randy, do you want to maybe share with the audience some of your thoughts on a framework moving forward, and then of course get Dr. Selby as well to comment on the kind of the vision of where we could be going or should be going?
Yeah, absolutely. First of all, I want to applaud Walt in his career. I'm working on some of the hardest problems this nation has in regards to critical communications for public safety. There's probably no greater mission to protect life, limb, and property in our country. So, Walt, thank you for that. The work is really important because it sets the fundamentals for the new age of the digitization of our economy that we're moving into. And we're no longer going to be only concerned about interoperability for voice, video, and data for people. We're going to be worried about interoperability for autonomous sensors and platforms, which brings an additional layer of complexity to every level of the stack. And we're going to start with the fundamentals. We have to start with the fundamentals as we reimagine a new architecture for mission critical communications, for sensors, for autonomous platforms, and for people to coexist in. And when I say reimagine that architecture, I truly mean that, because the antiquated way that we've approached the building of networks is to choose a protocol, to choose a proprietary radio on a proprietary network to move proprietary information with proprietary code. That no longer is scalable and sustainable. So we have to reimagine that reference architecture. We have to be spectrally agile and opportunistic to have networks choose the frequencies they need to operate to move data based on its requirement anywhere at any time. We need to be able to have portability of the data to cross network boundaries so we can leverage existing infrastructure wherever it is, whether it's a terrestrial network, a public network, a private network, or a satellite-based network, or all of the above, right? So heterogeneous. We need to be able to disseminate quickly through identity management and quantum encryption of the protection of that data where we process the data to get the information we need that's actionable, either for the autonomous platform or for the person. And that's where distributed AI at the edge is absolutely critical to this new architecture. So I could go on, but at my level, having spectrum agility, having quantum encryption, having dynamic routing, having distributed AI at the edge are all pieces of this new network puzzle, this new network architecture that we need to standardize on, so we can create data portability, interoperability, and sovereignty across any network at any time to deliver mission critical data across those boundaries, whether they're political boundaries, technical boundaries, or geographic boundaries. So I'll stop there.
So one of the and thanks for that. I mean, you've kind of laid out a whole national security strategy. But I think since we have, one of the things you mentioned is the ability to use what's available, no matter what it is. And one of the things I've learned in this area, and also working with Walt in the past, is what's available goes in two dimensions. Everybody thinks about cellular, but what's available now, we have space services, low Earth orbit, but we also can go the other direction, which is residential. So, maybe the phone network is there, maybe it's not there, but maybe someone's Wi-Fi at a coffee shop is there, and I, as the fire truck, can get on that. Or maybe I need to go the other way, or maybe I bridge. Maybe I use the satellite network to go up and then come down and to connect to somebody who's on a Wi-Fi network on the other side of the forest fire. So, I mean, Logan, since you're here, I mean, Walt kind of mentioned, and both Randy mentioned, network availability. Would you kind of share your thoughts? I know this is kind of your show, but
No.
What's the state of the art on understanding what's available from an RF perspective, so first responders know that it's even an option or not?
Sure. No, and I appreciate it. And Walt gave me flashbacks from when I was a second infantry lieutenant, coming up with my pace plan before movements. That was a common thing back. It still is common, and everybody does it. But it brought some memories back. But I think that goes along with the tools we have. There is technology that exists that can be distributed from an AI perspective. So today, everyone is very turned on to centralized AI. So everybody kind of understands large language models, deep learning, things that require a lot of compute that reside somewhere centrally. So in a server somewhere. So you're collecting all your data from peripheral sensors, and it's all being pushed back via that network to some centralized database. But people forget in critical communications that central database might not be available, and you might not have access to it. So that's why distributed AI is essentially critical for the future of these communication environments that we're going to be operating in. So putting these new tools that can be on the devices that first responders and people in critical situations are using to, number one, help them with their PACE plan. Like you mentioned, Junaid, if you show up somewhere, your primary communication methods might be disabled. So how do I find that alternate or that contingency or that emergency? Maybe I have a distributed AI solution that can assist with that while I'm arriving on the scene, number one. Number two, a solution like we have at Data Shapes, I have to throw my plug in, but having something that can assist with RF availability or just assist with the congestion. That's something that we deal with a lot on the DoD side with our customers, is the contested environment. But what we're talking about when we start talking civil military type operations, DISCA type stuff, is we're talking congested environments. So a critical event occurs, Boston bombing happens, everything gets so congested and prioritized that you don't really know what's happening across the spectrum. But having an agile RF solution that can assist first responders in understanding where those signals are going, what's happening, helping allocate resources via the spectrum to assist in communication resources being delivered faster is going to be critical as well.
It's a good thing he can edit this out.
Yeah, Logan, it's amazing. You probably don't realize it, but you froze up a couple times there during the last discussion, right as you're describing the issue and the impact of congestion. So you couldn't have timed it any better than that.
Yeah,
Now,
don't edit it out, Logan. Leave it in there.
yeah,
Yeah.
but
So,
imagine had that been during a middle of an active shooter scenario,
Sure.
and you're trying to make decisions as to what to do, and the screen froze up. You just showed us exactly why this is so important. But you were also talking a little bit about the analytics at the edge and stuff like that. So with the deployables that we're doing an awful lot of work right now to go ahead and also put medium-sized hardened servers right at the device itself, right at the edge of the network, so that when you've got first responders out there, they can do an awful lot of the analytics and a lot of the stuff like that. Video sharing should not have to go back to the cloud to be distributed across
That's right.
responders in a local situation. But one of the chip manufacturers that we're working with right now is taking it to the next step, is let's put the analytics in this device. Let's go ahead. The chips they're building now are unbelievably powerful as far as compute goes. So how much of those analytics and how much of that AI work can I push right out to the device? That's one of the big questions I think we're going to be asked to tackle over the next 2 years.
No, that's great, and that's and I would love to talk to you more about that offline, Walt, because that's exactly what we're providing. So we have a solution that you push, and we don't require a new chip. So data shapes, we go on legacy hardware, and we're doing that distributed processing. So we would love to talk to you more about that. But before I want to bring up something else, just because I'm curious. You mentioned how the Finnish and some of those groups you were working with in Europe, also the public safety also uses, and defense use similar networks, so the same networks for communications. How does that pertain to what we do from a defense to civil defense of civilian authorities, DISCA operations here in the U.S.? Is there, because I'm less familiar, I'm assuming there's probably disparate networks, and then that's probably a whole nother puzzle piece that we have to work with. But how is there lessons learned that we could bring from those countries that are doing that over to what we do?
Well, there definitely is, because when you talk about defense, everyone, the first thing that hops in their head is tactical operations. What do I do when I'm in Afghanistan or I'm in Ukraine? But realistically, there is a lot of interaction that goes on, especially in the public safety space, between the first responders on military bases and the first responders that are in communities immediately around the bases. If there's an active shooting situation today and people start dialing 911, depending upon whether that cell phone is connecting to a cell tower off base, or whether it's connecting to a cell tower on base, it's going to be routed to one of those two locations. And in either situation, the routing can be wrong. So how do I get the location information? How do I get all of that in there? Plus, as for example, if I'm on a military base and they've got mutual aid situation set up, which the majority of the bases do. You've got a large fire on the base. They're going to call in the fire vehicles and the ambulances from the surrounding community. How do I, you're dealing again with interoperability, but you're also dealing with interoperability between the citizens or the local responders network and the Department of Defense network. And the Department of Defense network is one of the most closed networks I have ever seen anywhere. And it has to be. It's done that way for good reason. But when I need to share information, how do I get that done? That's again, a tough challenge.
Walt, I'm glad you brought up the mutual aid agreement between DoD and public safety entities, because it's a voice-only mutual aid agreement. It does not include data. So there is no data mutual aid, and we're moving into a data-centric environment. So there's some policy that needs to be written or recognized. And then to Logan's point about public safety and defense on the same network, well, that may exist today. And if that network is served by the cell site on base is served by the same T1, when that T1 gets cut, you lose your commercial comms and your public safety comms. So there's no diversity, right, or redundancy in that architecture which we have to move away from, right? We have to reimagine, right, how to be spectrally agile and use what we have at that moment to get the data to the people or the things that need to receive it.
Yeah. And I think, fortunately here, we're better funded than a lot of the countries are in Europe in terms of network capabilities. But if you look at it, we have a dedicated defense network here, and then we have a dedicated public safety network. When you get to areas like Finland and Sweden, especially when you get to the northern part of the country that are very, very, very sparsely populated, there's no way that they could build two separate networks. So they have to work together a lot closer than we do in the United States. But that's, again, by running on two different networks. Again, in Europe, a lot of those networks are combined into one network, but they are still managed and operated by a group of the federal government. Sweden, for example, it's MSB. It's part of a lot of these are run by the Ministry of Interior, but there are typically networks that operate together and work together to support both public safety and defense. But no matter what we see, no matter how they're set up or managed, we're seeing two things that are similar. One of them is they're basically operating on the same systems that we are, primarily from the cores, it's Nokia, Ericsson, and Samsung. And then from the requirements and the capabilities, they've got the same questions we do. How do I deal with mission critical push to talk? How do I deal with side link? And how do I deal with inter-network connectivity and things like that? So the equipment and the requirements are very much the same, but how we do it is where the differences come in.
So, we're kind of at time, but as we wrap up, Dr. Magnussen, as you talk about all these options, as a last comment from you, would love to get your perspective on the importance of creating test beds. The thing that strikes me in this conversation is the sheer complexity, the RF complexity, as Logan talked about, the organization that Randy talked about, then the actual event itself. That I would think that not only doing test beds helps us, but I think what I get out of this is as we move into smart cities, smart transportation systems, that the notion of test beds itself needs to be enlarged and become more distributed. So it's just not the facility, but perhaps it's a facility in a city or state that's partnering for doing some scenario planning, or it's the test bed and multiple agencies looking at, a power outage. Like our last podcast, we focused on large scale outages on the energy grid. How would you deal with that if power goes out on multiple communications networks simultaneously? So you can have network diversity, but unless we test it, we won't realize that everybody's on the same power source and everybody's out. But as our kind of parting thought, could you just share your thoughts about the importance of or the value of testbed, and maybe even also comment on the importance of enlarging what we do from large-scale testing, because at this point, we don't do any large-scale multi-agency testing across America.
Right. Kind of the best example of that is basically now we've had two tests over the last couple of years on the IPAWS National Alerting System. It's amazing. It's been around since the 1960s, and it's now been tested nationally twice. That kind of tells you how you don't want to do things. Because basically, systems that are not tested are not mission critical. You can't wait until the day that you need it to really be able to use it. But also, there's three major functions that testbeds support, and we've, through some research that was done by the National Spectrum Consortium, they did a survey, and I think basically we found that the testbed in College Station at A&M is the most wide. It's got the broadest capabilities of any of the testbeds in the country. That really would help industry in about three ways. One of them is smaller companies, especially that are developing new applications, need to be able to have a place to go to test their applications, test their systems without building a complete LTE network to be able to do that. So you've got the development, and then you've got the integration. We're doing some work in GPS denied and PNT, position navigation and timing work right now. What happens when you lose your PNT signals, and how do you really back up from there? those have to be integrated into all of the other applications, because every application that's out there today basically heavily depends upon GPS to be able to operate. Back when you think about how dependent we are upon, how reliant we are upon GPS, it really kind of scares you a little bit. And then the last thing is demonstration. So if I am a company again and I want to be able to demonstrate the capabilities, how do I do that? One of the things we support in terms of getting that done is about every other year, we have what we call the Interoperability Institute. It's coming up this next year in May 6th through 10 here in College Station. And that will be then a 3-day workshop of the interoperability, what I consider the thought leaders in the United States, meeting for 3 days of discussing what all is going on. And we follow that up with a 2-day exercise. And the 2-day exercise will incorporate people from the Department of Defense, Department of Public Safety, Department of Homeland Security to be there. The FBI was there last year. So we bring in all these other agencies and we do a 2-day exercise. We show the new technologies and capabilities, often in a not ready for prime time level yet. Some of the stuff we've got, for example, it would be a TRL level 4. But we want to get them kind of understanding where things are going, and then also let them give us feedback as to, that's great, but how would I use it as an end user? That's the big thing that really is missing in a lot of these, is getting the technologies in the hands of the first responders and the people and the soldiers that are going to be using it before it's actually ready. And that actually then helps shape the development.
That's great, and that's actually a lot to think about, and probably we'll need further podcasts on this topic to look at the different aspects. And with that, I guess Logan, if you.
Yeah, thanks, Junaid, and thanks again, Dr. Magnussen, for joining us on the podcast. A lot of insightful thoughts. We appreciate you jumping on after you just got back from Poland, which I'm sure was an exciting trip. I'm sure it was an exhaustive trip as well. So we appreciate you jumping on. And Randy, as always, thanks again. Junaid, thanks again. And thank you to all the listeners out there. We'll see you next time.